So, all right, Freya. Right now, as you can see, I just have uploaded an image which has some uh, parent quadratic function. Parent, though we have the standard form like this. See, if we now replace the other side of the equation by a variable y or y as fx, then it's called as kind of function, right? It becomes a function. It's a quadratic function now. So the parent quadratic function is given by y equals x squared.
Yeah.
Yes, Priya. So y equals x squared. It still has the degree of 2, right? The power
Uh-huh.
highest power is 2. So it's still a quadratic equation, or you can say the function. And its parent form is given like this. So it has some characteristics actually. If we have y equals x squared, the parent function, so its characteristics basically means it's opened upward. It has some other values, some other objects like vertex. Vertex is the lowermost point this time, or it's also called a turning point. Vertex of a parabola. It's also called a parabola, in fact, and parabola's vertex is also called the turning point because that is where it turns. And the line that simply divides it from the middle, that's called axis of symmetry. It's called
Oh.
axis of symmetry. So, okay, though I have just shown you an example, but before that, I'll tell you some characteristics of this graph. Just 1 minute. Yeah, properties of the quadratic function, or yeah, just like this image, it will help you. That was a parent quadratic function. But if you talk about general, that's what we actually need. Standard form, or you can say the general quadratic function. So you already have learned the quadratic equation of that type.
Yeah.
Now, if it's represented as y variable, so we can plot it on the coordinate plane. So for plotting it, we need some concepts. So first of all, we need the turning point. The turning point, or before the turning point, we need the axis of symmetry. The axis of symmetry means its axis of symmetry simply bisects the figure into two equal parts.
Oh.
So equation of the axis of symmetry can be given because it's parallel to y-axis and it's intersecting the x-axis somewhere. So the vertical lines are always given as x. The vertical lines are
Uh-huh.
always given as x equals something, like x equal 3, x equal 4, x equal 5. So that's how, what right now we already have a, b, and c. If the equation is given to you, you can get the values of a, b, and c. So then you can simply substitute b and a in this formula, x equals negative b over 2a. This is the formula. That is where you can substitute the values. So you will get the axis of symmetry. And now once you get the value of x, you substitute it into the formula. Then you will get even the value of y at this point. So that will be your turning point. I'll tell you after solving it. But right now, let's say it's just xy, and that's a turning point. And the c term in the formula, c term in the equation of that is called the y-intercept. Do you know what's the y-intercept?
When the line goes through the y-axis.
Yes, either the line or the graph or the curve. If wherever it intersects the y-axis, that distance from the origin is said to be the y-intercept, right? All right. So yeah, we are all set now. So this is how we can get the y-intercept and the turning point as well as the axis of symmetry. So we'll have an idea how our graph will look like. I'll show you some example now. I have an image of an example as well. So we can actually get its axis of symmetry and the vertex and all. So look at the equation they have given. It says consider the function that's a quadratic function obviously, and it has this standard form at the left end, at the right end in fact. So first of all, you compare it with y equals ax squared plus bx plus c. So you will get the three values that I'll write over here. It's -2, a is -2, b is +12, and the c is just -7. Yeah. Now, if you want to get the axis of symmetry, formula for axis of symmetry we discussed x equals negative b over 2a. So I can just write down. I can write at the next page if you want. Axis of symmetry. Axis of symmetry is basically x equals something, right?
Yeah.
So it's negative b over 2a. Now the b value was 12. You can write just 12. And the 2a, a simply means a is just negative 2. So we basically have got what? It's negative 12 over negative 4. So x is equal to 3. We just get x is equal to 3. So that is the axis of symmetry. So if even if you want to plot it in the coordinate plane, I'll open the graph sheet. And together with that, we can also start plotting it. So this is my x-axis, you must be knowing. The
Yeah.
horizontal axis is said to be the x-axis. And the vertical axis is called the
The
y-axis.
y-axis.
Yes, that's the y-axis. And this is my x-axis. So now we have at least got the axis of symmetry, which is x equals 3. So it will intersect our x-axis at point 3, somewhere here. So okay, I can just draw a line which simply intersects over here like this.
Mm-hmm.
Yeah. Once we've got this thing, now we get the turning point. How do we get the turning point or that vertex? Because the vertex will definitely be lying on this line only.
Mm-hmm.
That means x component will be 3 for that. Wherever that vertex is, that x component will definitely be 3 and we need y component for the vertex. So x equal 3 will also satisfy the equation of the parabola that's given to us. So we now rewrite the equation. It's a negative 2x squared y is equal to negative 2x squared. And then after we have plus 12x minus 7. Just 1 second. Plus 12x minus 7. So that's what is our equation, and we already have got x is equal to 3. So at x is equal to 3, we may now evaluate the value of y. So it's negative 2 and 3, and then it's squared, and then after we have 12 times 2, and then it's minus 7. So y is equal to basically negative 2 times 9. Here it is.
Shouldn't it be 12 times 3?
Oh, yep. That's 3. Actually, I just made wrong. It's 3 basically. I accidentally written that. 12 3 the 36 in fact. It's just 36 negative 7. We can now evaluate it. It's negative 18 plus 36 negative 7. So we get 18 minus 7, which is 11, I guess.
Mm-hmm.
Y component we've got as 11. Yes, it was 11. So now we have got, the missing component that we needed was 11. So vertex will be somewhere. It's 3 comma 11 will be the vertex. Right now we have less space over here actually. So I can't draw 3 or even 3 comma 11 will be somewhere at the top. It's 3 and then
Um,
11 will be here. Yeah.
um, in the previous page, wasn't it negative 18 or something? And negative 18 and negative
Negative
7.
18 plus 30. Yeah. So negative 18 plus 36 will become positive 18, right?
Oh, okay.
Yeah. And 18 and negative 7 will just become 11.
Okay.
All right. Okay. No problem. So that's how the vertex, we'll get the vertex. Right now we are having just idea. So this is the vertex of the parabola, and we
Mm-hmm.
also have the axis of symmetry. Then we can have few more points. What we do, because we already have our equation, we have the equation as negative 2x squared plus 12x plus, is it 7? No, it's negative 7. Okay, no problem. So since we have this equation, so what we can do now, because we already have got some idea where is the axis of symmetry, where is the vertex, so we can use some random points around the axis of symmetry or at both the sides of the axis of symmetry. We can simply just get like x is, see, the x is equal to 3 is the vertex, right?
Mm-hmm.
So we can even keep it in the middle, like it's 3. Now we can have at just before 3 we have 2, before that we have 1, here we have 4, here we have 5. So that value of x we assume, and now we get the corresponding values of y. We already have calculated at 3. For other values of x, we can have some values, right?
Mhm.
And once we get them, we can then just get ordered pairs like that. Once we just substitute these values in the equation, we'll get the ordered pairs or the coordinates. And once we are done, what we do then, we simply know, see, this is a symmetry, axis of symmetry. Right now, we don't have much space over here, but let's suppose the vertex lies somewhere here, and we get some more points like that. Let's say we get 1 point like this, and 1 point we get like this. So symmetry by symmetricity, even here, we'll get some points like that, and even like this, right? And then after, once we get that kind of points, we can just complete our parabola like that. Like we can simply join the points. Right now the
Yeah.
points are not matching, but you can understand, we can just
Mhm.
join them using some like freehand curve. We can just simply join them. Right now I randomly drawn the points, so they are not matching, but once you draw it with the proper ordered pairs, you can just join it as a parabola. Okay. So, okay, Shreya, right now we have very less time left in our session because it automatically gets ended in 1 hour.
Okay.
So, yeah, we just have about 1 minute left.
Mhm.
So, I hope whatever we've done today, you must have understood. You can
Yeah,
tell
it
me.
was it was
Mhm.
it was clear. Thank you, sir.
All right. So, okay, no problem. So, hope to see you soon again. And I just expect that whatever you understood, feel free whenever we have the session. And if you have any doubt, any confusion, feel free to ask me even in the next session.
No
Okay.
problem. Thank you,
All right.
sir.
All right. Thank you. Bye bye. Take care.
Bye.
Bye.